This is lesson 4 on solving rational equations. A rational equation is an equation containing at least one rational expression. So this whole unit has been on rational expressions. We're taking those and we are putting them into equations. Working with rational equations is similar to working with rational expressions. So my steps for solving rational expressions are listed. Our first step, you probably won't be surprised, is going to be to factor and state the NPVs. Sometimes you won't be able to do this, so if you can't do it, or if you can't factor, you can skip this step, but please don't forget about those NPVs. Next, you are going to find a common denominator and convert fractions to have the common denominator. So just like adding and subtracting, find a common denominator and then make your common denominator. After that, you are going to cancel out the denominators and solve the remaining equation. At the end, check to make sure that your solution is not one of your NPVs. If it is, it's what we call an extraneous root. And we are also going to practice checking our answers. Our first example says solve the following equations and state the non-permissible values. So as I mentioned, that first step, factor, you don't have to do on some of these. I noticed that this whole equation, x over 4x minus 7 over x equals 2, is made up of monomials. So if I have monomials only, I can skip the factoring. However, it's a good idea now to state my NPVs. As we know, x cannot equal 0. Next, we are going to find a common denominator. So my common denominator here is going to be 4x. I need to get a 4x on the bottom of every single piece of this puzzle. So I need to get a 4x on the first fraction. Lucky for me, I already have it. I need to get a 4x on the second fraction. So in order to get that, I'm going to multiply by 4 over 4, just like we did with adding and subtracting. And then this 2 also needs a 4x on the bottom. I can put it over top of 1 to help me with my multiplication. I need to multiply it by 4x. So let's multiply those through and see what we end up with. We have x over top of 4x. 1 has not changed. Then we have 28 over top of 4x. And then we have 8x over top of 4x. So at this point, I see that there is 4x on the bottom of every single fraction. That's exactly what I want because now I can cross them out. And I'm left with an equation that looks like this. X minus 28 equals 8x. So now it takes us back to, grade 9 math where we get to solve this equation. I first subtract x, and if you like to think of it as 1x, feel free. That gives me negative 28 equals 7x. And then I divide both sides by 7, and I get my final answer of negative 4 equals x. I'm going to box up my answer. Negative 4 is not a non-permissible value, which is good. So now I'm just going to check my answer. So how do you check your answer? First, you sub the negative 4 back into your original equation. So here's my original equation. I take negative 4 and I put it in anytime I see an x. Make sure you put it in brackets. And here's where I'm going to turn to the calculator as well. So I'm going to type in negative 4 divided by, I have to put brackets on the bottom of my fraction here. Negative 4 divided by 4 times negative 4. Okay, That gives me 0.25. I'm just going to write that down. Then I'm going to subtract 7 divided by -4, negative 1.75, minus negative 1.75. And then the last step is subtract to make sure that in fact does equal 2.25 minus negative 1.75 gives me 2. Great. That's one reason why I like this last lesson the best, is it's easier to know if you for sure got it right. Okay, let's move on to a binomial as of our. Okay, next question says 2x over top of x minus 4 minus 6 over top of x minus 4 equals 4. So I can see that I don't need to factor, but I do need to state my non-permissible. My non-permissible value is x cannot equal 4. My common denominator for this question is going to be x minus 4. Now, the left-hand side of the equation already has x minus 4 as my denominator. I only need to create an x minus 4 on the right-hand side. So I'm going to multiply 4 by x minus 4 on the top and on the bottom. Okay, moving on to the second step, I'm just writing down what I already had and then showing here that when I multiply 4 times x minus 4, I get 4x minus 16 over top of x minus 4. Now, once again, you will notice that the denominators are all the same. Once they are the same, you can cancel them off and you'll be left with a 2x minus 6 equals 4x minus 16. So remember when you're solving these types of equations that you want to get your variables together first. So I'm going to move 2x to the other side by subtracting it, because that will cancel off the 2x on the left-hand side of my equation. I'll be left with negative 6 on the left-hand side, and on the right-hand side I have 2x minus 16. Okay, I now am going to add 16 to both sides. Negative 6 plus 16 is 10 equals 2x. And I divide by 2, get 5 equals. Now, I did not bring home my answer key, so I better check my work. 2 times 5 over top of 5 minus 4 minus 6 over top of 5 minus 4 equals 4. So I think I can do this one without my calculator. 2 times 5 is 10. 10 over top of 5 minus 4 is 1. Minus 6 over top of 1 equals 4. And I know that 10 divided by 1 is just 10. And 6 divided by 1 is just 6. So I get 10 minus 6 equals 4. And we get 4 equals 4. So that we did it right. Okay, we are done. It is now time for you guys to try the your turn. Pause the video. Here is my solution for the your turn. Pause the video if you need to check your answer. We are now going to move on to the next example. Okay, the next example says solve the following equation and state the non-permissible values again. You can see here that we have x plus 5 and x minus 5 on the bottom. And we also have an x squared minus 25. So here's where we have to bring that first step of factoring into play. So we have 2 over top of x plus 5, just recording as above. I'm going to leave a little bit of extra space because I know I'm going to have to do some multiplying. Remember that you need to work on showing your work. Try to show all of your steps so that it's easy to follow. So x squared minus 25, that's a difference of squares. So I know my common denominator is going to be x plus 5 times x minus 5. My non-permissible values for this question are x cannot equal plus or minus. Okay, so now I need to get that on the bottom of all of my fractions. So I need to multiply my first fraction by x minus 5. Notice how I put it in brackets. And I need to multiply my second fraction by x plus 5. Okay, my first fraction, I'm going to get 2x minus 10 on the top. The 2 gets multiplied through just like we did for adding and subtracting. And then the denominator is x minus 5, x plus 5. Okay, then we are going to add. Here we're only multiplying by 1, so it's just x plus 5. Multiplying by 1 doesn't change it, and the denominator is x plus 5, x minus 5. And then our last one is just as given. Now I have a common denominator on all my fractions. I can cancel them out, and I'm left with 2x minus 10 plus x plus 5 equals 7. Okay, let's collect our like terms on the left-hand side of my equation. So I get 3x minus 5 equals 7. Then I have to add 5 to both sides. Get 3x equals 7 plus 5, which is 12. And then my last step is to divide by 3. Okay, I get my final answer of x equals 4. All right, let's try the last one. So the last one, I have 3 over top of 2x minus 1 equals 4 times x plus 3. So if the denominators are completely separate, by completely separate, I mean that they're different binomials, what we are going to do is we are going to multiply the opposite fraction on the opposite side by the other denominator. So we are going to multiply the first fraction here by x plus 3, and we are going to multiply the second fraction by 2x minus 1. Okay, so I'm going to multiply the first side by x plus 3. And know that these types of equations here are quite common on the diploma exam, where there are two separate binomials involved. So the left-hand side needs to be multiplied by 3, or x plus 3. And then the right-hand side needs to be multiplied by 2x minus 1. So you saw this strategy when we were doing adding and subtracting as well. Okay, I am now going to multiply through, get 3x plus 9 on the left-hand side, over 12 plus 3 2x minus 1 equals 8x minus 4 over top of x 3 times 2x. Okay, now that I have my denominators the same, they both are x plus 3 times 2x minus 1, they can cancel. And I'm going to be left with 3x plus 9 equals 8x minus 4. Okay, I subtract 3x from both sides. Then I get 9 equals 5x minus 4. Add 4 to both sides. And I get 13 equals x. And my last step is to divide. So my answer is a little weird for this one, but it's just going to be 13 over 5. Okay, go ahead and complete the last 2 your turns, and then we will go through them in class on Monday, the next class.